Now, here are some solutions for some of the review problems I gave you for your exam. I'm going to be working on the geometric probability. And the first problem is we're looking at a point on a segment and the probability that it is on LN, so somewhere on that 10-unit segment. The way you do probability on a segment or length of time is you say the probability that x is on ln is the length of ln over the total length. So it's 2 plus 8 over 2 plus 8 plus 10 plus 4, or 10 over 24, which simplifies to 5 over 12. The next problem, we're looking at the probability that it lies in the shaded region. Now, you could normally do areas here, but since these are obviously equal areas, being a hexagon here, I can just count up the areas that are shaded, so it's 2 out of 6, or 1 out of 3. This next problem is a little closer to what you deal with in an area problem for probability. So I have two right triangles that are shaded, and they have bases of 5 and a hypotenuse of 13. If I could find this height here, then I could find the area of these triangles. So let's go ahead and use Pythagorean theorem. 5 squared plus x squared equals 13 squared. And you may recognize this as a triple. When you solve it, you're going to end up getting x is 12. So I could go ahead and do the area of two triangles, but the cool thing is if I take this piece right here on the left and combine it with the piece on the right, doesn't that just make a rectangle that's a 5 by 12? So I could say the area is 5 times 12, or 60. The area of the square is going to be 12 times 12. Remember, we figured out this height was 12 because of the Pythagorean theorem. So it's 144. The total area of my problem are these two triangles, or the 60, plus the 144, which is 204. The probability of being in the shaded area is the area of the shaded region over the total area. So it's 60 over 204, which simplifies to 5 over 18. For the next problem, we're looking at three frogs that are sitting on a 15-foot log. Frogs 1 and 2 are 5 feet apart, and frogs 2 and 3 are 10 feet apart. What is the probability that another frog will land between 1 and 2? So I basically need to know this length over total length. It'd be 5 over 5 plus 10, which is 5 over 15, or 1/3. So that was pretty straightforward. And then I'm looking at the probability of a pointer, and I did the even here, but this will still work. The probability of a pointer landing on orange. So I'm going to take the 70 degrees here over the total around a circle, which is 360, or 7 over 36. Now I'm going to add this extra problem. This is not on your worksheet, but this is a little closer to what you might see on your exam. What is the probability of landing on red than blue? So I'm going to take the probability of red, which is 40 over 360, times the probability of blue, which would be 30 over 360. I simplified these two and multiplied, and I got 108. So remember, when you have the probability of two events, one then the other, you multiply those probabilities. Now to the next side of the sheet. This is the practice side. Very similar to the first problem we did. We're trying to find the probability the point is between t and v. So I just need to take this length over the total, which is 6 plus 8 over 1 plus 6 plus 8 plus 3, or 14 over 18, which simplifies to 7/9. For problem 3, it's a lot like problem 3 on the other side. I could calculate areas, but I see that these are all equal areas, so I can just say, oh, there are 3 shaded over 9 total, or 1/3 probability. Problem 5 is probably a little closer to what you might see. So I have a right triangle in here, and I can tell this is a diameter because that's a right angle, which means this arc is 180. So that has to be a diameter. It's cutting it in half. I can find this leg of my right triangle by using Pythagorean theorem. 6 squared plus x squared equals 12 squared. Subtract 36 from both sides, and I get x squared is 108, so it's the square root of 108. And you could find your decimal value. I'm going to try and keep it in square root notation. And I know there's a 36 in there times 3. So my simplified notation is 6 square root of 3, which I can put up here on this leg. The area of the triangle is going to be 1/2 the base times the height. And it shouldn't matter if I turn this, the height could be 6 square root of 3, or it could be the 6, and the base would be the other one. So the area of the triangle is going to be 1/2 6 times 6 square root of 3, or 18 square root of 3. The area of the circle, that's going to be my total area. So remember, if I'm trying to be in the shaded region, I want the shaded area over total area. So I need to find the area of the circle, which is going to be pi times the radius squared. Well, 6 is half of 12. That's your radius. So the area of the circle is 36 pi. Therefore, the probability of being in the shaded region is the area of the triangle over the area of circle, or 18 square root of 3 over 36 pi. I could simplify that a little bit more to square root of 3 over 2 pi. Now problem 7, we're looking at the probability of the pointer landing on red, so this is a lot like the previous one, and we would just say 20 degrees over 360, which is 1/18. Finally, problem 9, a certain company plays classical music when its customers are on hold. If the length of the complete recording, Mozart's Eine kleine Nachtmusik, is 2 hours long, what is the probability a customer put on hold will hear the Allegro movement, which is 6 minutes 31 seconds long? So we have to find out the total time. Well, it's a 2-hour long composition. So let me change, it's easiest to change everything to the smallest unit, which is seconds here. So I'm going to say the total time is 2 hours times 60 minutes. And each minute has 60 seconds. So it's going to be 7,200 seconds. All right. Well, I'm going to find out that the Allegro is going to be 391 or over 7,200 seconds. And I accidentally skipped a step, which is how did I figure out that 391? Well, the Allegro time is 6 minutes, which I have to multiply by 60 seconds, plus the 31, or 391 seconds, which gave me my probability of 391 over 72.